Okay, so now we need to talk about gas exchange. So gas exchange is a result, or understanding it has to do with Dalton's law. So we're going to be talking about partial pressures. So I'm going to make a weird picture. So I'm going to make my little lung or alveoli, same thing, starting with the trachea or whatever, and then I'm going to make a big old okay. So this is my little alveoli, and then we're going to make some vessels here. And I'm doing this a different color because we want to show oxygenated and deoxygenated, right? Okay, and then down here we have our little tissues. So here's our tissue cells. All right, so I'm going to divide my little lung in half. And on this side, I'm going to show air coming in. And on this side, air going out. Okay? So in the atmosphere, we're talking about partial pressures, and we're talking about oxygen and CO2 as far as gas exchange. So we're not talking about just air that you're breathing. So the PO2, so that's the partial pressure of oxygen, is about 160 millimeters per mercury in the air. And the PCO2 is about 0.25 millimeters per mercury, so in the atmosphere. So this is in the atmosphere, okay? All right, so when you take a breath in, so breathing in and oxygen is coming in, the PO2 in your lung after you breathed in is about 100 millimeters of mercury, okay? So that's where you breathed in this oxygen coming in. At the same time, you've got carbon dioxide that is coming from blood that is coming back to the lung. So the PCO2 is about 40 millimeters per mercury of mercury. So it's about 100 millimeters for mercury in the lung for oxygen, and about 40 for the carbon dioxide when you breathe in. So when blood is moving, deoxygenated blood is moving toward the lung, oxygenated blood is moving to the tissues. Okay, so when deoxygenated blood gets back to the lung, the PCO2 is about 46 millimeters per mercury. So that is why, I guess I should have used this color, but okay, 46. And that's why it moves into the lung, because in the lung, it's 40. So if it's 40 here and 46 here, it's going from higher to lower. It is going into the lung. The PO2 in deoxygenated blood is about 40 millimeters per mercury. So at that point, then, oxygen goes into the blood. And when it goes into the blood, because it's 40 here and 100 here, so it's moving in, it moves in till it gets about 100 millimeters per mercury. Okay, now carbon dioxide just left to go into the lung, so what's left is PCO2 is going to be 40 millimeters per mercury. Okay, so now the blood is on the way to the tissues. When it gets to the tissue, remember, PO2 is 100 millimeters per mercury. PCO2 is 40 millimeters of mercury. Okay, in the tissues, as it gets here, the tissues need it. The tissues have been doing metabolism and whatever, so they've been using their oxygen and getting carbon dioxide as the waste product. So the PO2 in the tissue is going to be 40 millimeters per mercury. And then the PCO2 is going to be 46 millimeters of mercury, because it's using its oxygen and it's creating CO2 as the waste product of metabolism. So once the blood gets here, PCO2 is 40, it's 100 here, oxygen goes into the tissue, and carbon dioxide goes into the blood. So we're left with a PO2 in deoxygenated blood of 40 millimeters per mercury and a PCO2 of 46 millimeters per mercury, where carbon dioxide went into the blood. So we get back up here and same thing happens. So we get our PCO2 goes into the lung. You could probably like put that over here. So the PCO2, and then the CO2 then is exhaled. Okay, so that's how gas exchange occurs. What affects things that affect gas exchange? So let's look at factors that affect gas exchange. One is the partial pressure differences. So these numbers, if they vary, if there's your capacity to breathe in oxygen is diminished, you're going to a higher elevation or something like that, then gas exchange is going to be affected if this number is different as you breathe Another thing is the distance between the alveoli and the capillary. So this distance here. So if there's pulmonary edema and the distance is more, like let's say it's here and then it got to be this much, then it's harder for the gas to move across than this membrane here. For CO2, a lot easier because CO2 is more soluble in fluid than oxygen. So it's harder for oxygen to travel a further distance to get into the blood than it is for the CO2. So that brings us to the solubility of the gas. So again, CO2 is more soluble in water than oxygen. So it will move easier and travel easier. 4 is the surface area of the alveoli. So if the alveolus gets larger and there's any damage to the walls of the alveoli, like an emphysema, which causes the alveoli to get really big, then there'll be less ability for the gas exchange to occur. All right, so that is basically how gas exchange occurs. So if you have any questions about that, we'll talk about that in class, but you probably need to go through this a couple of times to get it. So don't feel bad if you don't understand it at first. And don't get hung up on these numbers. Remember, the numbers don't really change. It's either going to be 100, 40, or 40 and 46, depending on if you're at the tissue or what you're in the lung or whatever. And these numbers here don't change. This is just what it is out in the atmosphere. All right, so next we will talk about how oxygen moves.